In this video, we're going to go over slope, and we're going to use the example from the previous video where the slope was equal to a positive 2. But for now, let's go over the definition of slope. Slope is often known as the rise over the run. And what that's saying is that it's the change, so the change in the vertical rise over the change in the horizontal run. So the change in y over the change in x. And this is also known as the rate of change. So when you hear the rate of change, think slope. To write slope as a formula, we're going to do the change in y over the change in x. So the slope we're going to say is m. So m equals the change in y. What exactly is the change in y? If we have 2 points, the change in y is the y-coordinate of one of those points subtracted by the y-coordinate of another point. So we need 2 points to start. Our 2 points are going to be x sub 1 and y sub 1. That's one coordinate that lies on the linear equation. The next coordinate will be x sub 2, comma, y sub 2. So for our change in y, we're going to take one y-coordinate, y sub 2, and we're going to subtract that by the other coordinate, y sub 1. So that is the change in y. The change in x, we're going to follow the same format. We're going to take one x-coordinate and subtract the other x-coordinate. So we're going to take x sub 2 and subtract x sub 1. The order you subtract the coordinates must be the same. So if you take y2 and subtract y1, you must take x2 and subtract x1. If these coordinates were flip-flopped, and you take y1 and subtract y2, then you must also take x1 and subtract x2. So it doesn't matter which coordinate you use as x1, y1, and x2, y2, it just matters the order in which you subtract. So on our graph from the previous video, let's go ahead and pick 2 different coordinates. Let's go ahead and just use our y-intercept and our x-intercept. Our y-intercept, if you remember, occurred at the point 0, negative 4. Our x-intercept occurred at the point 2, 0. So let's go ahead and write these coordinates as x1, y1, and x2, y2. So for our x1, let's use 0, comma, y1 would be negative 4. So we're using the point 0, negative 4 as x1 and y1. As x2 and y2, we're going to use the other coordinate, 2, comma, 0. Now, let's plug these points into our slope formula. So we're going to get that m is equal to y2 minus y1. Our y2 is 0. Our y1 was negative 4. So 0 minus negative 4 all over x2, which is 2, minus x1, which was 0. That's going to be 0 plus 4, because when you subtract a negative, it's the same as adding the positive. So 0 plus 4 over 2 minus 0. That's going to leave us with 4 over 2, which 4 divided by 2, we know, is a positive 2. And remember, from our equation, our m was indeed equal to 2. So that's how you find the slope using the slope formula. But let's look at what that means on the graph. Remember, we said the slope was the rise over run, and slope is equal to positive 2. So moving towards the right. We're going to do the rise starting at the point 0, -4. So we go up 2 and over 1. So our rise is 2 over 1, which was our run. Our next rise going up 2. So now we're at this point here. Let's do the slope again. We're going to go up 2 in the vertical direction, so our rise, and we're going to go over 1. Again, 2 over 1. And 2 over 1 is equal to a positive 2. So that is what the slope looks like on a graph. So if you're given a graph and not the equation, by moving from one point to the next, you would easily be able to calculate the slope, the rise over the run. Let me give you a few other tips when dealing with slope. We see that the slope for this line is a positive 2. If it's a positive slope, as you increase x, so as you move to the right on your graph, if it is a positive slope, you will move up in the y. So for a positive slope, as x increases its value, y will also increase its value. So this is how we know it's a positive slope. Let's look at an example of a negative slope. So next we're going to look at y equals -3x plus 1. In this, we know our m is -3. So our slope is -3. Let's go ahead and graph right away our y-intercept. So for our y-intercept, it's going to occur when x is 0, because that's when it's going to cross the y-axis, and that occurs at 0, +1. Now let's apply our slope. Our slope is -3. -3 in fraction form is -3 over 1. So our rise is -3 over our run of 1. So we're going to go down 3 in the vertical direction because it's negative, but we're still going to go over 1 in the run because 1 is still positive. Now from this point, go down 3 and over 1. If this was reversed, say we did a +3 over a -1, we would start at a point. So let's start at our middle point, go up 3, since our rise is +3, but now our run's negative, so we go to the left 1. And you can see that we get our y-intercept, which was where we started. So 2 points make a line, but we have 3, so let's go ahead and connect those points. And here, you can see our negative slope. So our positive slope, as x increased, y increased, but for a negative slope, as x increases, y decreases. So for a negative slope, we're going to go down as we move to the right. We've accounted for when m is positive, and we've accounted for when m is negative. But what happens when m is 0? Well, let's take a look at that. Let's say y equals 0x plus 4. 0 times x is always going to be 0. So regardless of your x value, you're always going to have that y is equal to 4. So if x is 0, y is a +4. If x is 5, 1, 2, 3, 4, 5, y is still a +4. Let's say when x is a -2. -2 times 0 is still 0, so y is still a +4. So let's go ahead and connect that line. So when the slope is 0, we're going to get a horizontal line. So that means for whatever value we plug in for x, y is always going to be the same value. Notice that each of these three are functions. If we do the vertical line test, our vertical line is only going to intersect each equation at one point. There is one more type of line we haven't covered on this graph. We have a positive slope, so going up to the right. We have a negative slope, so as we move right, we're going down. We have a horizontal line, where the slope is 0. And now we're going to see an example when the slope is undefined. That occurs when we have a vertical line. In this vertical line, x is always going to be equal to 7. So for this vertical line, the equation would simply be x equals 7. X is always going to be 7. Y could be 1, 2, 5, 20, negative 50, so on. But x is always going to be 7. This last example is not a function. That is because you can see on the vertical line test, as soon as a vertical line hits this graph, we're going to get multiple y values that match to the same x value. And remember, in order to be a function, each value in the domain can only match to one value in the range. But here, the one value in the domain, 7, matches to multiple different values in the range, or multiple different y's. So this last equation is not a function. So we have positive slope, negative slope, the slope as 0, and the slope when it's undefined. In the next video, we are going to go over one more form of a line for a linear equation. We've already went over standard form, and we've went over slope-intercept form. In the next video, we're going to go over point-slope form.